While in the PIP this semester, I have learned valuable lessons about teaching science. According to Molly Weinberg in her article, A Leg or Three to Stand On, elementary science instruction should emphasize all three legs of science: content, process, and nature. While many teachers emphasize knowing and doing science, they often overlook teaching students about the nature of science. Four elements of the nature of science are that science is tentative, it is based on evidence, it is repeatable, and it is a human endeavor. In both science lessons that I taught in my PIP class this semester, I made sure to emphasize the nature of science. The first science lesson I taught in my PIP was my formative assessment lesson about erosion. The content standard for my lesson was 4-ESS2-1. Make observations and/or measurements to provide evidence of the effects of weathering or the rate of erosion by water, ice, wind, or vegetation. In my lesson, students simulated the effects of rain on barren soil and observed the water running off. Students created their own land and water models using plastic bins, soil, and spray bottles with sprinkler heads attached to the top. The lesson started with an investigable question, a continuation from a probe administered the day before. How does precipitation, specifically rain, affect land? Students wrote their predictions and then tested them using the materials provided. In the end, they were asked to answer the question again, this time using evidence from their exploration. One of the important components of the nature of science is that it is based on evidence. By requiring students to provide evidence to support their claims about the effect of rain on soil, the students were learning about the nature of science. The second lesson I taught in my PIP was entitled By Golly by Gum and was adapted from a lesson I found in a book given to me by my cooperating teacher called Jawbreakers and Jaw Thumpers. In this lesson, students used the scientific method to discover what happens to the mass of gum when it is chewed. They measured the mass of different brands of gum before and after chewing using a balance, collected data in a table, and organized it in a graph. The standards being addressed in this lesson were NGSS process standards. First, analyzing and interpreting data. Analyze and interpret data to make sense of phenomena and using logical reasoning. Second, planning and carrying out investigations. Make observations and/or measurements to produce data to serve as the basis for evidence for an explanation of a phenomenon. Like in the erosion lesson, my students were engaged in learning about the nature of science as they made conclusions based on evidence and were all involved in the process. In the elaborate phase of the lesson, I asked the students to come up with other investigations we could do based on our findings. They suggested we repeat the same process but with different flavors of gum, or changing the amount of time that they chewed. They were learning one of the key elements of the nature of science. Science is repeatable. In planning lessons, it is important that teachers consider the developmental stages that their students are in so that they can construct a lesson that is age appropriate. According to Piaget's theory of development, the students in my class are in the concrete operational stage of thinking. This stage of development is sometimes titled the practical child. Children at this stage are very curious and demonstrate logical, concrete reasoning. Their thinking becomes less egocentric and they begin to realize that their perspective and feelings may differ from those around them. During the concrete operational stage, most children still cannot think hypothetically or abstractly. Instead, they develop meaningful understanding through experiences with concepts. Both science lessons taught in my PIP involved hands-on experiences that were developmentally appropriate for children in this stage of development. In my erosion lesson, students had the opportunity to experiment hands-on with the effects of rain on soil. Although the probe pushed them to think hypothetically, they were able to test this hypothetical thinking with a concrete experience. Students were broken up into 4 groups so that each person would get a chance to participate in the investigation. As students observed with their own eyes what happens when rain hits soil, they developed a deeper understanding about the effects and causes of erosion. In my second lesson, the students also had the opportunity to engage in hands-on learning experiences about the change of mass in gum before and after chewing. They used the data they collected to create a class graph and compared the amount of mass lost after 10 minutes of chewing between 4 different brands of gum. Through the investigation, students discovered that gum loses a large percentage of its mass while being chewed and came to the conclusion that the mass lost was in large part due to the sugar being dissolved. They came to this conclusion without me telling them. Because they were able to test this question hands-on and discover for themselves, rather than simply being told or reading about it in a textbook, the learning was much more meaningful and developmentally appropriate. Assessment, both formal and informal, is a vital part of effective instruction. According to Paige Keeley, the best type of assessment is one that is embedded within instruction. Authentic assessment does not aim to assign a child a grade, but to determine what children know and where to go next. Before developing my erosion lesson, I administered a pre-assessment probe to test my students' prior knowledge about the effects of rain on soil. I showed them a picture of a rill forming during a rainstorm and asked them to say whether it would get bigger, smaller, or stay the same as the rain continued. I used the information gathered about students' background knowledge from this probe to help me when planning my formative assessment lesson. After teaching the lesson, I re-administered the formative assessment probe to see how students' understanding had changed from the beginning of the lesson to the end of the lesson. Throughout the lesson, I also administered formative assessments such as Fist to 5 and Paint the Picture. By golly by gum, I started the lesson by asking the students the question, what happens to the mass of gum after it is chewed for 10 minutes? Students wrote their hypotheses at the top of the page in the form of a phrase, I think the mass will blank because blank. After the lesson was completed, I had them revise their original hypotheses and write the reasons for their answer. This served as a pre-assessment and post-assessment of student learning. My cooperating teacher and the students in my class had a positive reaction to both lessons. The students loved the hands-on experiences involved in both lessons, and of course were very excited about the opportunity to chew bubblegum in class. After finishing my erosion lesson, my cooperating teacher told me, I think you're the only person who can make erosion so much fun. Kelly Lynch, my supervisor for the PIP, was able to watch me teach my formative assessment lesson about erosion. She left me this note when she left. Overall, both science lessons went well and were positive learning experiences for both me and my students. Based on my assessments, it was clear that the students came away with a better understanding of erosion and measurement and data analysis. If I could do both lessons again, I would spend more time in the class discussion during the explain phases of the lesson. This is always the hardest part of teaching lessons for me because I often forget the exact questions I want to ask in a class discussions and am sometimes thrown off by students' responses. Going forward, I know that I will have to plan thoroughly for class discussions and anticipate possible student responses. Another takeaway from both lessons was how helpful formal assessments really are in gauging student understanding and growth. Thank you so much for watching my Science iMovie, and thank you for a great semester. In the words of Bill Nye, science rules.